is indeed accelerating. So let me repeat, even though the speed is constant, but still the object is accelerating, primarily because of the fact that the direction of the velocity is constantly changing in the circular motion. Hence, the answer for this question is option D, 1 and 3 only. So here we have a box kept on an inclined plane and it is being pulled by a force F, which is at an angle of 30 degrees like they have shown, and the angle of the incline is also 30 degrees. We need to figure out the work done by the force F on the box. All we need to do is just apply the basic formula. Work done is Fs cos theta. Now theta is the angle between the force and the displacement. So we need to be very careful. How is the object moving in this particular situation? Since the object is kept on the inclined plane, so let me draw the direction of displacement. The object will be moving up the incline like this. So this is the displacement S. So now we can clearly say that the angle between force and the displacement is 30 degrees. Hence we can write here F into S into cos 30. Now in the question they have given that the value of displacement is d. So distance traveled up is d. Now be very careful in the formula for work done, which is F into S into cos theta. S is displacement. S is not distance. So we need to be careful about that aspect. But in this particular situation, since the object is moving in a straight line, which is along the incline, but it is a straight line. So if you recall in situations like these, when the object is moving in a straight line, then displacement and distance, they are equal. Hence, we can say displacement in this situation will be equal to distance, which is d. Hence, we can say that the work done in this case will be F into d into cos 30, which is option A. Option A is the answer to this question. In this question, we have been given two masses 1 kg and 2 kgs, which are connected by a string. 1 kg rests on a rough surface, so the surface is having friction, and another 2 kg object is connected vertically like this. Now, it is mentioned when the objects are released, the masses accelerate at g by 2, which means in the diagram, we can say 2 kilogram is going to accelerate downwards with an acceleration which is equal to g by 2. Similarly, for the 1 kg block, it is going to accelerate towards the right hand side with the same acceleration g by 2. Now, the acceleration of both the blocks is the same only because they are connected with a single string. It is mentioned that the work done by tension of the string on the 1 kg mass is 40 joules. Which of the following is correct? We need to figure out the force of friction acting on the 1 kg block and distance traveled. So how do we approach such questions which are connected object questions? Step 1 is to draw the free body diagram of both the objects. So let's start with 2 kilogram mass. So the first force acting on the 2 kg block is the weight itself, which is mg. So in this case, we will write 2 into g. That is the weight. And then we have the tension acting along the string going away from the object. So T will be acting upwards. Similarly, on the 1 kg block, let us draw the forces. So we'll have the weight 1g acting downwards, which will be balanced by the upward normal reaction. Then the block is having a tension acting towards the right hand side. Now, since it is mentioned that the surface on which the 1 kg block is kept is rough, so it is going to have friction. Now, since the 1 kg block is moving towards the right, so friction will be towards the left as friction opposes the motion. So this was step 1, identifying the different forces acting on the object. Step number 2 is to identify the net force which is acting on the object. So for the 2 kilogram block, there are two forces acting, 2g downwards and t is acting upwards. So the net force will be 2g minus t. So we subtract them. So basically what we are doing is we are using the Newton's second law, F net is equal to m into a. For the 2 kg block, which was this, the net force was 2g minus t. So let's write down on the left hand side, we'll write 2g minus t will be equal to m into a. Now mass is 2 kilogram and acceleration is g by 2. So we will write 2 into g by 2, which can be written as just g. Hence, the equation becomes 2g minus t is equal to g. This implies t will come out as 2g minus g, which is equal to g. And the value of G we can take as 10. So T will come out as 10 newtons. Hence, the value of tension acting in the string is equal to 10 newtons. Now, let us apply the same equation F net is equal to MA for the 1 kilogram block. So on the 1 kilogram block, vertically the forces are balanced. So the net force will be T minus the friction. Since T is acting towards the right, friction is to the left. So the net force will be the subtraction T minus F. So for the 1 kg block, let us write, let's write the main equation first. F net is equal to MA. So for the 1 kilogram block, the net force is T minus F. So let's write it down. T minus F equals to mass is 1 and the acceleration is the same, which is G by 2. Tension we had found out was 10 newtons. So we will write 10 minus F equals to, the value of G is 10. 10 upon 2 will give us 5. Now, if we simplify this, we will get the value of friction as 5 newtons. Now, if we go back to the options, column A denotes the force of friction. So we have figured out force of friction was 5 newtons, which means A and C can be discarded. Now, to get to the right option, we need to figure out the distance traveled by the 1 kilogram block. So how do we do that? In the question, it is specified that the work done by the tension is 40 joules. So let's write down work done is equal to 40. Now we will use the basic formula for work done, which is F into S into cos theta, where the force involved is T, tension in this case. So we'll write, in place of work, we'll write T multiplied by the distance traveled, which we need to find. And in this case, the angle theta will be 0 degrees. And why is that? T is acting towards the right hand side and the object is also moving towards the right hand side. Hence, the angle theta will be 0 degrees. So on the right hand side, we will write 40. Now, the value of T, the tension we had figured out was 10 newtons. So the equation becomes 10 into S into cos 0 is 1 equals to 40. Now, if we simplify this, we will get the value of S as 4 meters. So the distance traveled by the 1 kilogram block is 4 meters, and hence we can say option B is the right answer. All right, so far we have discussed how to find the work done by a constant force. The formula was W is equal to Fs cos theta. Now, do remember what are the conditions under which that formula is applicable. That formula is applicable only when all the parameters involved are constant. That means force, displacement, angle, everything should be constant. Only then we can apply W is equal to Fs cos theta. But in situations where force is variable, so the magnitude of force is not constant. In that case, what do we do? So let us discuss. So we already know the formula Fs cos theta, but this is only applicable if force is constant. If the force is variable, then we find the work using this. So work is equal to the area under the force displacement graph. So even though here I have mentioned that this formula is for a variable force, but area under the force displacement graph you can use in any situation. If the force is constant or variable does not matter, you will always get the right answer if we do area under the force displacement graph. But if the force is constant, then you can use the formula Fs cos theta. The only catch here is Fs cos theta will not work if the force is variable. So in any general situation where the force is either constant or variable, we can find the work by area under the force displacement graph. So how do we do that? There are certain steps to it. So imagine we have this graph where on the y-axis we have force, x-axis is displacement, and the graph looks like this. So what are the steps? Step 1 is to draw a dotted line perpendicular to the displacement axis. So all we need to do is look at this end point of the graph where the graph ends. We need to draw a dotted line which is perpendicular to the displacement axis like this. That is step number 1. Step 2 is to find the area between the graph, the dotted line, and the displacement axis. So in this case, this purple line is the graph. We have the dotted line and the displacement axis. So all of this area is what we are supposed to find. So the magnitude of this area will give you the value of the work done. But sometimes the examiners might interchange the axis. So consider this image. We have on the y-axis, we have displacement. See, originally in the left side, we had force on the y-axis. But sometimes the examiners interchange the axis. So y-axis is displacement, x-axis is force. So even in this case, the steps will still remain the same. Step 1 is draw a dotted line perpendicular to the displacement axis.